Hello everyone, welcome back to our platform of Educator's Mind. So we will be continuing to discuss the question of JEE Advanced 2020. Let us start the next question number 11, section 2, paper 1. So what this question is saying, shown in the figure is a semicircular metallic strip that has thickness T and resistivity rho. So we have got a semicircular metallic strip and it has thickness T, but that thickness is inside this plane, isn't it? That's why it is not represented in this figure. And it has got some radius, inner radius R1 and outer radius R2. Okay, and resistivity is also rho. If voltage V0 is applied between its two ends, so we have voltage, a battery having voltage V0 is applied across its two ends. Okay, a current I flows in it. In addition, it is observed that a transverse voltage delta V, a transverse voltage of delta V is developing between its inner and outer surfaces due to purely kinetic effects of moving electrons. Ignore any role of the magnetic field due to the current. Then figure is symmetric and not drawn to scale. Okay, so the current which is uh, due to this battery is not producing this transverse voltage. This voltage transverse is produced due to the motion of electrons. Okay, it is given in this question. Now we have to choose the options. Option 1, if you check A number option, this is telling about the current. So we need to derive the current, isn't it? Voltage is given, radius are given, R1, R2. So area is also given. So based on that, we can calculate the resistance. Yes. And then Ohm's law, I is equal to V by R. So resistance calculation we need to do first. Then we have to also discuss the voltages, which surface is higher voltage and lower voltage. Okay, and then this potential transverse potential is proportional to I square. This we need to derive. Once we derive out the resistance, from there we derive out current, and then we will see how to derive the voltage. Okay, so then let us go to the solution, how to do this. Yes, so we will first make a rough diagram of this semi metal semi metallic strip, semicircular metallic strip. So we can say it's like this, and I can make this also thickness. It's just like a magnet, like a U-shaped magnet, isn't it? So of course this is shape is semicircular, and this is the inner base, and there will be, of course, this also will be there. Now the thickness T is given of this. This is the thickness T, and this is, let us say, the center. From there this radius is R1, and this radius, outside radius, is R2. Okay, this radius is given, and this material is having a resistivity of rho. Now one thing we can say that, of course, this I will draw not as dotted, but I will connect it, because dotted lines means which is hidden. So this is what we can see in our view, right? This will be we can able to see that. Yes, so this is visible to our eye. So that's why let us make it with a solid line. So visualization is also very important in physics. Some lines or some diagrams we can see directly, something is hidden inside. For that we can use dotted lines. So if you have to draw dotted lines, you can draw dotted lines for inner lines, right, which is hidden, which is not visible in the front view. Correct. Okay, anyway, now the thing is that we need to show how the current is going. So it has been connected, this part is connected to positive terminal, and this portion is connected with negative terminal. Yes, so this side is positive and this is negative. The voltage is V0. So current direction, how the current will be flowing. Yes, so current will be going in this direction, isn't it? I can make the direction of current like this. So what will be the direction of flow of electrons? So electron always flow opposite to the direction of current. So electron will be flowing like this. Yes, electron will be moving like this. Okay, so we can conclude from this itself that this is a circular motion. Electron is moving in a circular motion. Yes, and because there is a circular motion, there will be a centripetal force. Yes, acting towards the center. So if centripetal force experienced by electron is toward the center, the electric field must be acting opposite, or you can say radially outward. So electric field E is radially outwards. Yes, we can write it is radially outwards. So if electric field is radially outward, this means what? This means inner surface must be having higher potential. Yes, so we can say the inner surface is at higher potential. Yes, higher potential. So from here itself we can conclude that the option number which can be correct, the option which can be correct, that inner is higher potential, outer is should be lower potential. Yes, so outer should be lower voltage. So C number is correct. Now we have still not derived that other thing. This is just a qualitative analysis based on which you can tell. Now let us first of all find out the resistance. So for finding the resistance, what I am going to do, I will be making an element here, a small element which you can all see, that a small element will be made like this. So in the same diagram, although it's looking like very complex, but we can represent it here, a very small element. So this element which I have chosen here, how this element is looking like, you can see from this diagram. I am also just putting this color so that you will be able to visualize this. Okay, so this is how this element which I have chosen. Now this element I am taking right now at some radius. We need to certainly choose a radius for this. So at what radius this element is, you can see this element is at a radius of r, and the element has got some thickness. Yes, some thickness, let us say dr is the thickness. So then we can able to write, yes, we will be able to write what, the resistance, a small resistance of this small element. Let us say that a small resistance is dr, is resistivity into L by E, right? What is the length? If you open up, so the direction of current is important, because based on that we should take the perpendicular cross section area, right? So current is going like this. So perpendicular cross section area means this area. Yes, this is how we need to consider this area. So what will be this area? Yes, so this is dr into t. Yes, so resistance into resistivity. Resistance is resistivity into length. Length is first and then area. Area is, we have told, T into dr. And then what will be the length of this? Length will be pi into r. Then we need to integrate this and solve. Okay, so that we will do here. Now let us write that. So that dr, resistance, is resistivity into pi r by t dr. And if we integrate this, yes, let us integrate this. So what we are going to get, that will be the resistance left hand side, and here pi rho is constant, and we can write the integration. The denominator t is also constant. We can write this dr by r, and this radius is varying from r1 to r2, correct? So if we can solve out, this is pi rho by t, this is ln r2 by r1, isn't it? So this is resistance. Now what is current? I is equal to v by r, v naught by r. So we need to just substitute this v naught. And what is this resistance? If you substitute, this will come T ln R2 by R1 divided by pi rho. Yes, and you can see this is the option number A. Option A. This is option A. So we have got option A and C. Now we need to check about the option D, which is potential difference. Yes. So from here we can understand one thing, that this force, there will be a force, centripetal force, that we are talking here. This centripetal force is nothing but the electronic charges into the E. If we are considering just one electron, of course there will be so many electrons. Just for the sake of analysis we are writing this. Okay, so this will be nothing but mv square by r, mv square by radius. Okay, and here this v is the drift speed, because electron is drifting towards the left side with this speed. So we can also say that this electric field is proportional to this drift speed square. And what is drift speed? Yes, so we have seen that electric field is proportional to drift speed square. Yes, so drift speed in terms of current, we know current I is equal to NEAVD drift speed. So this means current is proportional to drift speed square. So this means electric field is proportional to current square. Electric field is also proportional to voltage. So the voltage is proportional to current square. Why? Because we know electric field and voltage, there is a direct relationship, isn't it? So we can also conclude from this analysis that this delta V is proportional to I square. Yes. So we can choose option number D also. So here option A, C, D are correct option. Yes. So I hope that you have got a feeling about solving this question, although this question and a little bit complex, because there are analysis involved of mechanics also. The mechanics part is also involved here. Yes, so you will be seeing that this electron, so this is the major thing here, the electron is experiencing a centripetal force towards the radius. Okay, so the drift velocity is this side, so there is a electric field acting opposite. Why? Because positive charges move in the direction of electric field. Okay, move means the force that is experienced by the positive charges in the direction of electric field, and electron experience a force opposite. So if the force is acting in this direction, so that's why the electric field is in this direction. And you also know that along the direction of electric field, potential decreases. That's why potential of the inner surface is larger than the outer surface. Fine, so I hope all of you can understand this explanation, and thank you for watching this and paying attention. We'll see in the next class with the next video. Bye bye all.